Hello, for those of you who don't know, my name is Paul Binner, and this is my video for the 3D Printing Advanced Machine Design assignment. So the first topic that we were asked to talk about was an application of 3D printing that we could use in our home. I don't know about you guys, but I have a bunch of cords laying throughout my house, and one particular pile that is just incredibly stacked up. The cords get very easily tangled, and it's a real pain to deal with. So one application I would use a 3D printer for is an organizer where you could just slip them on. So you could see each individual cord, something that would hang down. You could organize it from like different lengths or different use. So a cord organizer would be a big application I would use personally in my own house. So we've talked about some various different 3D printing methods in class, and obviously the best one is kind of relative to what its use is for. But the one that I believe is one of the best is DLP, or Digital Light Processing. And the reason I say this is because it's the fastest of 3D printing methods. And for a lot of uses, especially in industry, when you're looking for uses of 3D printers, it's mostly for prototyping. So a lot of times in industry, 3D printing is used for prototyping and not for actual pieces that are going to be used or sold. So with prototyping, the best thing is to focus on the speed of getting it out. If you have a big project that's coming up and you want to make sure that you can get it done as quick as possible, obviously you want a fast 3D printer that can get material out in a relatively quick manner. The way that DLP printers are able to do this is through the use of liquid plastic resin and arc lamps, which dramatically increase the speed at which the plastic is printed and hardens. DLP can also do things with very good accuracy. So between speed and accuracy, that is the reason why I picked DLP to be the best 3D printing method. An article that I found really interesting on 3D printing had to do with metal 3D printers. So metal 3D printing has been around for not too long, but it's still relatively new. But I believe that it has a lot of room for growth, and it's really cool. So with metal 3D printers, a lot of it is done to prototype parts, kind of like plastic 3D printers, but it can also be used for parts that are actually used for certain assemblies for parts. It's used in the military for replacement parts and also for individual parts as well. I'm sure most of you know Mitch, who is a machinist and a professor here at Wilkes. Machining is very good and you can get very good precision out of it, but 3D printing with metal is actually starting not to overtake machining, but it is greatly decrease the time that it takes to create parts through machining just by printing it. So if you want a prototype, you don't have to spend hours or even days to machine it. You can just get it 3D printed in a very quick manner with similar structural stability. In reading this article, I was actually surprised to find out that 3D printing with metal can actually be done with most metals, such as stainless steel, copper, titanium, and many others. Apparently there's a lot, and they didn't get into much detail, but I know that there's a lot of different metals that you can use for that, so I found that very interesting. So some of the manners in which 3D metal printing is done is with a metal filament, by powder bed fusion, and also by selective laser melting. They all have their drawbacks and advantages, whether it's done for speed, for prototyping, or for a very strong part. As 3D printing has continued to progress, they have started to integrate CNC onto the 3D printing machines itself. So you can get a basic mold printed through the 3D printer, and then the CNC can come around and get the part up to a certain tolerance, which may be hard to do with just the metal 3D printer itself. So it's an integration of both metal 3D printing and I guess a little bit of machining, but it's all done through the help of machines, I guess, and not a whole lot of human effort has to go into other than programming it. So it's very interesting. As I mentioned before, metal 3D printing is still in its infancy stages, and I believe that there's a lot of improvements that can be made through both the cost of how things are made, the speed, and the structural stability. Thanks for watching. I look forward to watching some of your guys' videos and commenting on them, and I'll see you in class. Bye-bye.